Hello, hello. Good morning, everyone. Thank you for joining us. Uh, I will wait a minute or so to make sure that all the attendees, or at least most of them, are here. Okay, let's start just with a little bit of introduction and get to the very rich material we have today. So again, good morning, good afternoon if you're joining us from far away. Uh, Thank you for joining us. Thank you for attending this technology talk of BEPA. My name is Bozor Kambai. I'm the Executive Director of Batteries European Partnership Association, BEPA. We are very pleased to have you and also have presentation and invitees representing the European projects under the Bat4U partnership. So Bat4U projects are here. We're going to hear from them, and we're going to hear from one of the very important ones. One of them has been concluded successfully, and another one is picking up the flag and moving moving with the accumulated knowledge built up. So today we're going to talk about the battery passports. I will spare you with the importance of this very crucial technology for Europe. The initiative and the forefront in this idea has been the European Union and European continent at large. The importance of the traceability of the materials, the inclusion of the transparency throughout the value chain, throughout the life cycle and lifetime of the technology. All of these have been materialized in an idea, in a vision on the digital product passport for the batteries. We call it battery passport. But this is a very difficult task. This needs a lot of conceptual thinking and also a lot of data. These are a lot of experience in many different aspects and many different scopes. The digital part is an important influential pillar for that, but also our understanding of the batteries, our understanding of the value chain and supply chain, our understanding of the relationship between different actors in the ecosystem is deterministic for the successful outcome of this idea. So still we need to invest on the research and innovation on this idea, and it takes time. We have to continue on the progress of this. We have had some pilot level launches from different organizations. There are many organizations throughout Europe that are working on this with different forms of public-private partnerships. But the basic idea of enriching the transparency and again enrichment of the data of this is still an ongoing activity at the research organization, universities, and R&D labs of the companies. So we're gonna hear a lot about this, why it is important, how it's going, a lot of very interesting details about that. But before that, just quick announcements and quick introduction. So if you don't know about us, we are the representative of the R&I of the battery sector to the European Union. So we represent the private side of the partnership Bat4U under Horizon Europe. We have a very vast number of members and very diverse number of members. We try to be the voice of the funding and the support for the battery sector in Europe, primarily the support from the European Union. and of course a lot of activities around that to make sure that the ecosystem is coherent, the voice is coherent, and the message is coherent, and the progress is visible, and the trajectory is the optimum coming from the public and private sector. Just a quick announcement about the events. The Battery Innovation Days are our flagship event. The registration is open. Please register as soon as possible. As you know, usually we have a limited number of seats, and thankfully, and thanks to you, it has become a very popular event. So if you would like to be there, I really recommend to register as early as possible. Just for the a quick reminder also for the BEPA members, if you're BEPA members, as you know, our tradition is to having the General Assembly the day after that. You have received the save the date. You will have the ability in the registration for the Battery Innovation Days that to mark that you will attend, just to make sure that your travel arrangements is also set and you won't go back after the BIDs. Please, if you intend to be at the BEPA General Assembly, make sure that you also take that into consideration for the travel. Just very last announcement. This takes a lot of representation itself, but with the help of the other association, Brussels Recharge, we are developing an action plan for the batteries per se, a kind of a manifesto for the batteries to really come out of this zone that we are at the moment and really project the promise, project the needs of the battery sector at a different level, at different pillars to the broader policy politicians and public servants. This is documented under what we call the Battery Deal for Europe. We will launch this document on October 23rd, so stay tuned. This is going to be kind of another call from our side, from the private side, from the stakeholders active and engaged in this value chain to the broader policymakers. So with that, I start with the presentations of the first project. So Ali Bouvon will present to us the project TranSensus LCA. Ali is from CA from France, and I just sorry, okay. You will give the presentation of the project too, but just a little bit of details that this is the project jointly developed by the other automotive association 2.0 and Bat4U. So comes from a collaboration on that side. Both sectors really identified the need to tackle this. Project has been concluded. We are very proud of the result. We are very proud of this project, and give the floor to you, Ali. Please let us know what happened, what are the results, and enlighten us on the methodology and data. Please.
Thanks very much for the introduction. So indeed, I am Anneline Vivant, and I'm going to present you the TranSensus LCA project, European project on environmental and social life cycle assessment. The project has started in 2023 and it has ended during this summer. So now we have all the results to present to you, and I'm very, very happy to do that today. So I will speak on behalf of the TranSensus Consortium, of course, because many partners have participated to this project. And I will give you a brief overview of the project, but you can go and see all the deliverables. So what are the motivations for this project? As you all know, now it's time to assess the ecological footprint of our product and services. And a lot of things are still missing. Standardized and comparable and data, but also method and tools that are for LCA, strategy and definitions, knowledge and skill, etc., etc. Well, there's a lot to do to result in a single harmonized assessment of the ecological footprint. Next slide, please. So that is why, of course, we have the chance to have the TranSensus LCA project. So the goal of the project is to develop a commonly accepted and applied single LCA methodology. So all the rules, clear requirement to give a guide on how to do the LCA, life cycle analysis. And the goal is to do that for zero emission vehicles. In this project, many partners have participated. Between then, it was a mix of industrial and also of research partners, so 11 industrial partners, 9 research partners. And this is very important in such a project to have both academic and industries, and also 24 associated partners. So, of course, coming from all Europe. So, because we want to have a LCA methodology that is accepted and applicable by industries and academics, we have gathered in this project, so industries and academics. And for all the requirements that we have defined, there was a clear decision-making process to define requirements that are achieved after a consensus is reached. Here you have a schematic of the decision process, starting on the left from the work coming from the beneficiaries of the project, so all people directly involved inside the project. But you can see that associated partner, the advisory board, industry and scientific, and also consensus liaison group are all involved in the decision making to reach really in a methodology that is achieved within a consensus. Next slide. So what is the state of the art for LCA methodology for zero emission vehicle? This was the first part of the project. And what are the main findings? So the first point is that today there is a lack of harmonization in all the methods to apply the LCA for the zero emission vehicle. That was really confirmed during the state of the art review. And really the goal of our project is going to fulfill this to fill the gap. For instance, before the project, if you consider one study for LCA of an electric vehicle and one other study with the LCA, if you compare the results, it's very difficult because you have many discrepancies between the hypotheses, between the methodology, etc., etc. So it was very complicated, and we try to answer to this gap. What we found also that is that there was some aspects that were already some good requirements, but some points were still debatable, so we have to answer to that. And for the approach, it should be policy relevant, clear, and methodological. And well, there were some direction that we could find in the state of the art. We did not invent everything. Of course, we wanted to start from the existing things, but many things have to be done. So the high-level needs are to get something understandable, to get something standardized, accurate, auditable, accepted, reliable, and trustworthy. There are also some other points of, let's say, lower priority, but of high importance also. And one of these points is the alignment with the current legislation and already existing guidelines and standards. In the project, we have considered that misalignment is also possible in case it would add value. And of lower priority, but also important, of course, something simple and transparent. So now, what is the TranSensus LCA approach? So first, as a support to the project, we have considered an ontology. The ontology is something that guides us to structure, to organize, and to link the data elements. So it's something very well structured, and it's nice to have it to facilitate the communication when several people talk about something, or to define very clearly what we are talking about. For that, we used an already existing ontology coming from the project Orient, and we have just adapted it. So in the ontology, you have some example here. You have perhaps some instance, some classes, etc. And with an ontology, you have a clear definition of each element of the relationship between them. Next slide. As support for the project, we have also defined a decomposition tree of the vehicle. So our project is the LCA of the whole vehicle, not only the battery. The battery is in the vehicle, but we consider the whole vehicle. So for that, when somebody talk about one component or an etc., there are some it may have the misunderstanding from the vocabulary. So we have defined a structure of the vehicle. So the whole vehicle, its system, subsystem, etc., up to the component. And for that, we used both a grid decomposition of the vehicle and the battery decomposition coming from the GRC draft at the moment. And it is to clarify when you talk about BOM or etc. So these two tools, decomposition tree and ontology, were used during the project as supporting tools to help us and facilitate the project. However, they are not today part of the rules and the requirement of the guideline to establish an LCA. You can use it, it's an help, but it is not the list of the requirement that we have given. Next slide. So what about all the requirements that we have given? So I will give you some of them. You will have them in the complete guideline. It is public. But how to consider it? First, we have defined different levels of requirements. Some are mandatory, some are recommended, some are only optional and informative. And in the guideline, we used a clear vocabulary, each time the same term, to be very clear of on the type of requirement it is. For instance, when you use shall, it means that the requirement is mandatory, and you have to apply it if you want to claim that you follow the guideline. And for the adherence of the guideline to the guideline methodology, to the TranSensus LCA methodology, we also have defined two levels of adherence. Level A is that you have followed the guideline to establish your LCA analysis, and you completely fulfill all the guidelines. So perfect. But there were some difficulties for some industrial in the part concerning the results that should be publicly reported because of confidentiality reasons. So therefore, we have defined a second level, level B. So if you claim that you have applied the TranSensus LCA methodology, and if you are level B, it means that you have applied all the requirements, but in the public reporting, some parts are kept and are not displayed. So the list of the displayed and non-displayed part is, of course, specified and defined in all the guidelines. Next slide. So here is the final consolidated guidelines. So if you follow these guidelines, you have all the rules to do the harmonized and LCA life cycle analysis for vehicle. This guideline is available. You have the link. You can go to see it, and you can use it. Of course, this is the goal. It is divided in 4 parts. The first part gives you all the requirements to do the LCA for the environmental analysis traditional. So this is the part A, ELCA. This is the main part of the guideline. But you also have a part which gives you the requirements if you want to apply a social LCA. We give all the rules. You have a part on the reporting, so what rules you have to apply when you report your results and you report all the hypotheses, etc. And you have finally a part on the perspective for future research. In the next slide, I will only talk about the environmental LCA. So when you do environmental LCA, life cycle analysis, there are 4 phases. The first phase is to define the goal and scope. Then the second phase is to define the life cycle inventory. The third phase is the life cycle impact assessment, and the fourth and last phase is the interpretation phase. We have followed the same steps, and for each step, the guidelines give you the requirement that you have to follow to do correctly your LCA, which is harmonized. For the goal and scope, the mandatory requirements. So here are only some examples. It is not exhaustive at all, but 2 main topics are very important topics. There are the functional unit and the system boundary. So for the functional unit, the requirement of the TranSensus LCA is to have a functional unit according to vehicle types with a default lifetime. And for the system boundaries, we require to go from cradle to grave with the list of the default process to include and exclude, which is given, and rules also on the cutoff point. So in the next slide, there are a little bit some more detail about all this. So here you have the functional unit for each type of vehicle. So in the TranSensus project, the vehicles that are considered are what we have called in our project the zero emission vehicle. So battery electric vehicle, fuel cell electric vehicle, fuel cell range extended electric vehicle, battery EV with electric road system, and we have also included the hydrogen fueled internal combustion engine vehicle. So if you want to use the TranSensus guideline, it is applicable for all these kind of technologies. And for the types of vehicle, it is applicable to passenger cars, light commercial vehicle, heavy-duty vehicles, and some powered two-wheelers. And here, just for illustration, for the functional unit, if you take the example of the passenger car, the specification is to have a functional unit that is the passenger per kilometer, with a different assumption of one passenger per car. So it is equivalent to vehicle per kilometer. Additionally, in the guideline, we also give some default values. And here you have the default value that you should consider for the product lifetime of the vehicle. So here it is 15. Can go to next slide. So this was about the functional unit. About the system boundary, so we specify to use a cradle-to-grave approach. That is to say that we start from the extraction of all the material for the mines. We consider the production of the vehicle, of the battery and the components and of the vehicle in our parameter. But we consider also the use phase of the vehicle, its lifetime, but how you drive it, etc., during the lifetime. And we consider the end of life of the vehicle with its recycling, for instance. So cradle to grave is the complete system boundary. We list in the guideline all the items to be included and excluded. Just to give you an example, for the second use of the battery, by default, we exclude it from the study so that we can compare all the results of different studies easily on the same basis. But you may include it as an additional scenario analysis in the last phase of the LCA, so the interpretation phase. And we also give rules on the cutoff. Next slide. So the second phase when you do a LCA is to do the inventory, so the list of all the inputs, process and material, etc., during all the life cycle. For that, we have structured the requirements according to the different stages of the life cycle. And we, in the guideline, we cover different topics, so several topics. So requirements concerning the battery, the primary or secondary data. So requirements on the primary data, how to model the electricity and hydrogen production, how to deal with multifunctionality when you have to consider it in your system of product, and also some points about the data quality assessment. So the next slide is going to give you more details about all these items. So here, for each topic, so for the production stage modeling, for your use stage modeling, and for the next stage also on the next slide, you have a list of requirements. So here, it is not detailed, but you can see the kind of items that we have considered. For instance, for the production modeling, how to model the electricity energy supply with some guide and some rules to follow. How to model the energy requirements of the vehicle. So if I describe this example, in the requirements, you have to model during the use phase, you have to model the energy consumption the same way as described in the UNICA LCA by default. So it is based on European certification, European some test, and we ask also to add some real-world factor adjustment and also some degradation factor. So degradation factor is especially for the fuel cell during the time. So here I will not display and comment all the requirements, but you can go to the guidelines and see all the details for each. And in the second slide, the same. So if you continue production phase, use phase, then end of life stage modeling. So the guidance, how to deal with multifunctionality problems. So we describe the approach and how to deal with the data quality ratings. For the third phase of the LCA, you have to do the life cycle impact assessment. And here, first, you have to define all the categories of impact assessment that you are going to calculate. So here on the slide, you have the list of the mandatory impact categories that you have to consider to follow the TranSensus LCA project. So first, of course, climate change, but not only. You have also to assess all the other impact categories that are listed here. So photochemical ozone acidification, particulate matter, it's important for vehicle, eutrophication of freshwater, cumulative energy demand, the resource use, mineral on metals, also very important for the battery. And in case of vehicle using hydrogen, also something on the hydrogen emission flow. The next slide.
Sorry, and just to quick reminder, maybe you don't have the clock around you, but we have 3 minutes left, so
okay,
just to keep that in mind. Thank you.
Yes, no problem. So for the last phase, this is the interpretation phase. So there are also many requirements. We define all the mandatory parameters that you have to investigate in this last phase, etc. So you can go to the next slide. It would be quick. If you go to the guidelines, there are also guidance on all the non-mandatory aspects, optional or recommended. So please go to the document and we'll have all this. And one last thing that I would like to say is that during the project, we have at the final stage a kind of test of the guideline that we have produced. And what I want to tell you is that this part is very important. So the goal was to take the guideline that we have defined during the project and to try to apply it to test if it is applicable, feasible, etc., if it is clear. And this part is very important because it gives you very feedbacks and some loops to refine your guideline to make it more clear. And really, we are happy to have tested it. Yeah, so at the end, we have something very non-brevity, for instance, on the vocabulary, on the understandability, etc. So please, if you define a guideline, test it and make it test by different kind of people. So now I think we can go to the conclusion. If you can switch. Yes, just for information, we have studied if it was applicable to other industrial sectors. So you have also a deliverable for that to other sector. So as a conclusion, there is clearly a need for a standardized methodology on how to do a LCA for an electric vehicle in Europe. The TranSensus LCA methodology now gives you an answer. It has been built and it is a success because it is really a consensus between both researchers and OEM. And now please go to the site, go and upload the guidelines and use it. And if needed, send us your feedback. Thanks very much.
Thank you so much, Anli. Thank you. You really gave us the assurance that we have the basis and foundation to act on. So we are. It was very evident that why we are so proud of this project. It checks a lot of boxes, and it really gives us the proper ontology and methodology to build on that. So as you mentioned, just
Thank you.
invite everyone to use it, to read it. This is very extensive material, comes from many partners in the sector. So please apply that and make use of it. From our side, thank you and congratulations to all the partners. It has been really an exemplifying project. So thank you. Now we know that we have a very good basis. We have the foundation and we have the LCA almost settled. Now it's the work of the implementation and put that into the actual digital battery passport, and that is within itself a huge task, both on the software side and the hardware side, and many of the provisions that should be around that. So we are following that up with another Bat for You project that I think has started last year. I think you have had your first your anniversary, so congratulations on that. But the project is called Base, and we are very much happy to have Dr. Shaheen Jamali. Shaheen is the head of monitoring and artificial intelligence at Fraunhofer IEG, and he's the coordinator of the project. And we also have Farhadur Arefin. Farhad is from Technonative Solutions from the UK. There will be a joint presentation. So without further ado, I give the floor to you guys. So please.
So thank you a lot, Bozorg, for the nice introduction, and hello and welcome everyone to the webinar. I want to firstly thank BEPA for organizing such an event so we can all get connected. So to just start, I will be giving an introduction about the BASE project, which is a Horizon Europe funded project in collaboration with BEPA, but the name of the BASE project is what defines the project, and that's basically stands for Battery Passport for Resilient Supply Chain and Implementation of Circular Economy. So our aim is basically to develop a battery passport that has the consideration of the resilient supply chain, and also we implement circular economy. So to give you a brief overview about the project and the information around it, the project is a Horizon Europe project, as I mentioned before. We have 19 partners within the project from 12 countries. And as Bozorg mentioned, we are going to run for 36 months, and we are almost reaching more than a year into the project. The main goal of the project is to develop, validate, and implement a working digital battery passport. And to achieve that, basically, our main goal has been to have 4 main use cases in 4 main aspects of batteries within the value chain. The first one being in the automotive sector, we have e-bus EV platform, and the use case is being led by Mercedes-Benz. So that's the first use case that we want to basically develop and demonstrate the use of battery passports. The second one is a frugal EV platform, which is led by Ford Otosan or Ford Automotives. The third one is a maritime use case, and basically we have electrical tugboats, a full fleet being run by Navtec, and the battery solutions and technologies provided by Corvus Energy. That's the third use case that we want to develop for the maritime use case and aspects of the batteries. And the fourth one is the stationary use case, which is being led by B-Planet, as you can see the partners on the right side. And the stationary use case will be led by B-Planet. But to give you an overview of the consortium, as Bozorg mentioned, Fraunhofer is basically coordinating the project, and we have multiple partners that are developing the technologies, including Technovative Solutions, Seraph Arctic, and we go down, and in order to basically have the consistency and also expansion into the whole value chain, we have all the people from the use cases studies down to the mining, like SQML rock metals, and that's basically the whole and totality of the consortium. So to give you an idea about the consortium, and then we have the 19 partners, and in the next slide, I will tell you why I gave a little bit more of an introduction about the consortium. Next slide, please. So the project goal, as I was mentioning, is to develop, validate, and implement a working digital battery passport service as mandated by the EU regulation. But the whole idea on top of it is just while we are doing that, we cover the whole value chain. And that has been one of the main goals of the project. And that's why I was introducing the use cases. So what we want to do is to cover all the implication of the digital battery passport within the battery life cycle. And that starts with mining and refining, as you can see in the figure. And then, in the first life of the battery, for example, in an EV, in the EV bus, in the tugboats, and then moving to the next section of the life, that's the second life of the batteries. For example, we have one of the use cases as a stationary use case. That's where we are introducing the second life of the batteries, and then going to the recycling, and then back to the whole value chain again. So that's the whole idea and the goal of the project, to develop, validate, and implement it within the whole life cycle of the batteries within the value chain. So basically, that's the whole goal of the project. And next slide, please. As Bozor was mentioning, there are going to be a lot of challenges, and why we are trying to do the battery passports has a lot of reasons, but there are three main challenges from the circularity aspect. And these three main challenges that have been identified are: the first one is the lack of traceability and sustainability within the supply chain. That's one of the main challenges within Europe right now. The second one is lack of resiliency within the supply chain again. And the third one is lack of circularity in the battery value chain. So one of the main goals of the battery passports in general, and consequently within the base project, is to overcome these three challenges as much as we can. And then there has been objectives defined for the project to overcome the challenges. And these objectives are the ones that we try to achieve within details to basically overcome the challenges. And the main one being developing a trusted, interoperable digital battery passport framework and platform, which would be the base of the base project, and then ensure that we have value within the value chain, track and traceability throughout the whole life cycle, as I was mentioning before. On top of that, what we are trying to do is to employ advanced analyticals, for example, for the state of X's, and also AI techniques to estimate the remaining useful lifetime of the batteries, and also bring circularity indicators accounting for the 4R methodology, which is very, very important. That's reduce, repair, reuse, and recycle, to bring and enable the value chain to consider the 4R methodology. On top of that, this is also very important. One of the main objectives that we have is also to develop a harmonized ESG indicator, that's environmental, social, governance, and economic, to also have these considerations on top of the battery passport. And then develop a business model for everyone to be exploiting it, and at the same time, bring the circular economy aspect into this. And bringing all these objectives together, we go to the final objective of the whole project, and that's to demonstrate and validate the DBP concept with all the objectives that I was mentioning above. So that would be basically, I will try to be short and compact with all my, so I will not go into the impacts. So next slide, please. So how do we want to do that? There are two figures on the screen right now, the concept and architecture of the DBP platform. So I will try to introduce the concept, which would basically cover the architecture. The architecture shows how the concept is organized. So basically, we start with the physical layer, and all our partners and associated partners and the whole battery value chain basically will be the physical layer, starting with miners, refiners, battery OEMs, down to recyclers. And this first physical layer will be connected with a hidden service layer, and that's the authentication, authorization, data space, and DLT, distributed ledger technology-based data audit. So this one, the service layer, will be the microservices and modules that would enable the connection to the physical layer. After the microservices and modules, we have two blocks for analytics and data space. The first one being analytics, as I was introducing before, and that was one of the objectives of the project, is we are developing already four main aspects for the predictive AI and the analytics. The first one is the state of X, like state of charge, state of health, a circularity indicator, ESGE, and finally LCA, which will go into the details within the second half of the presentation by my good colleague Farhad. And then after that, we will have another block for the data space, and that would be basically connected to the last one to basically transfer these predictive AI and analytics as analytical results, performance BP, internal services, and the federated catalog. And bringing and unifying all of this, we will have the last block, that's the application. Basically, that's the user interface and how users are interacting with the digital battery passport and all the things that are in previous layers that I introduced to you. And that would be user management, which user is going to have access to what, the partner management, data registry, and a semantic hub. And all these blocks as a concept is basically organized in the figure on the right, and that shows how all these tools are interconnected and functioning together. Next slide, please. So developing this architecture, the concept and objectives, bringing them together, the most important aspect of the project will be demonstrating these. So not to develop, not to just implement, but also to demonstrate the whole digital battery passport and all the other layers that I just introduced to you. So we have the 4 use cases, which I already introduced in the first slide. And what we want to achieve within each of the pilots would be to basically show that we have the possibility, not as base, but within the EU, a secure and reliable access to a federated digital battery passport infrastructure, which has a systematic, immutable data inputs to it, with the user management, DLT, and all that I mentioned. On top of that, very, very important, that would be the transparency, accuracy, and reliability of the battery indicators, which was, for example, the state of X, the remaining useful lifetime, and the circularity index. Then we want to show that the DPP data provisions can be implemented within a realistic product development lifecycle. That was the whole value chain. And then in the end, wrapping everything up by having real physical data from real use case demonstrations to show the circularity aspect, the ESG analysis, and also the business impact of the digital battery passports. Last slide, please. And to show you how we are doing it in the project, so we have just put the work packages structures. So we have the first work package, the technical work package, is the work package 2, which we focus on identifying the solution requirements and defining the KPIs. In the middle, we have work package 3 to 6. That would be basically battery performance, durability, and safety indicators, which I showed in the predictive AI and analysis. We have one work package dedicated to the circularity calculation methodology. The next one is the ESG indicators, and all these 3 will be basically unified within the developments of the battery passport and the platform within work package 6. With work package 7 and 8, we demonstrate and do the business modeling. And now at this stage, within work package 4 and 5, we are developing a lot of LCA technologies on top of what you just heard within the last presentation. And I give the floor now to my good colleague Farhad, which is the technology manager of the BASE project, to introduce you into the LCA developments that we are doing within the BASE project. Next slide, please.
Thank you, Shaheen, for your good introduction. So I'm Farhadur Arifin from Technomotive Solution Limited. So Technomotive Solution is established in 2012. Okay, so we are developing a lot of digital solution for different industries. So in BASE project, we are developing a digital platform, digital data space, and also digital tools such as circulating calculator, and also life cycle, also LCA tool. So I will today my scope will be only in the carbon footprint for the battery or the LCA tool. So next slide, yes. So the outline, I will explain about the carbon footprint for battery and its regulation. So what would be the methodology for the carbon footprint calculation, and the life cycle process for the battery, what are the challenges, and finally I will try to explain how we will try to tackle those challenges with the help of our BASE project. Next slide, please. Okay, so why carbon footprint for batteries? Because battery is a very critical device for the Green Deal and the climate target for 2030 or 2050. Okay, so how to and we try to find out the hotspot of the EVs or energy storage batteries. Okay, so that we can reduce the carbon footprint further, and it will impact a very complex supply chains. So, but the main enabler for the carbon footprint study and to develop the methodology is basically EU battery regulation, which enforced already in 2030. So where the carbon footprint declaration is mandatory. Next slide, please. Okay, so if we deep dive the battery regulation, we can see the carbon footprint has a different timelines for carbon footprint declaration. We have EV batteries declaration at 2025, and then we have the rechargeable industrial battery declaration 26, and then also the declaration for LMD. So this declaration should be included also in the digital product passport. Then also we have to provide the performance class for the batteries, and it will start from 2028. And then the regulation said that we have to also provide the maximum life cycle CAP threshold. So it will be enforced. Okay, so it's starting from 2029. Okay, so here all the EV batteries, what is the scope of these carbon footprint calculations? So all the EV and industrial batteries which has greater than 2 kWh must have the carbon footprint declaration. So, and the new rule is coming, so which is PEF rules. Okay, so I'll discuss more about these things. And the regulation is like in 2025 we have the declaration mandatory. To 2026 we have the performance classes, and then threshold enforced in 2028. Next slide, please. Okay, so let's discuss about the PEF. So PEF is enforced by EU. So EU tried to harmonize the LCA methods. Okay, so there are a lot of LCA methods, a lot of methodologies. So the PEF is stricter compared to all the LCA methodology. So it has 16 categories and requires the EF compliant datasets, and it will ensure the comparability across the manufacturers. So by this way, the different batteries can be compared. Okay, so which is currently is very difficult to compare because different industry are using different technologies and different methodologies. So next slide, please. Okay, so if we compare between the LCA and, please next slide, yes. Yeah. So if we compare LCA with the PEF, so system boundaries, so it was flexible in the LCA, like it could be cradle to gate, cradle to grave, or gate to gate, but in PEF methodology, we have mandatory cradle to grave methodology. So functional unit, it was varied, and different industry are using or different product from the different company are using different functional unit, but in PEF it was declared what should be the functional unit. So inventory data. So previously different peoples are using EcoInvent, Grid, Gabi databases. Okay, so the data quality is varied. So here we have the environmental footprint database. Okay, so or at least it should be EF compliant dataset. Allocation rule, there are some adjustment in the allocation rules. Previously, it was the industry's choice, but in PF they have the strict hierarchy. And impact category, I already told that it was 16 category, but in ISO standard there are depending upon the methodology, there are different impact categories. So next slide, please. Okay, so I have 4 minutes. So in the batteries, we have 2 classes now. We have the EV batteries and the industrial batteries. So even in these 2 battery categories, the aspect, for different aspect, they have different rules. For example, in the system boundaries, in EV, so in the system body in EV and also industrial battery, they have almost the same system boundary, like cradle to grave, but excluding the use cases. But for functional units, you can see that in EV we have 1 kilowatt hour of total energy delivered, but for industrial battery they have the different functional units. Yes, so please next slide. So next slide, please. So if you see here the industrial batteries processes, so in the red boundaries, these are the manufacturing processes, and all these data should be mandatory company specific active data. Okay, so and for other, which one is the black boundary, it could be secondary data sets. Okay, so these are the one of the main challenge in a PF methodology. So next slide, please. Okay, so let's talk about the challenges to perform the PF. We have a data collection burden. Okay, so how to collect all this data from different supply chain actors. So please click a second. Okay, then we have a complex global supply chain. So materials come from the diverse region. Okay, and PF requires that we need regional specific data. So it's very difficult to get those data. Next. And so far we have a lack of PF compliant background data. Next one, please. So end of life modeling. So PF already provided some guidelines, particularly for the battery, the carbon footprint formulas, and full impact coverage. Sometimes it's very hard to get those data from the industry. And the last one, and so verification and compliance is another problem. Okay, to tackle this problem, so in the base project, so we are using the data space concept for DPP, and we design the DPP, and also on top of that we'll try to develop the LCA or PF tool. Okay, so that the data exchange between the different actors will be trustworthy, and it will be an agreed principle, and there should be the data sovereignty. That means the owner of the data has the full control of these things, and also we will make sure that the data is, that means we will follow the ontology, the battery ontology there. Okay, so this is our main concept in the base to develop the full architecture with the data space. Next slide, please. Okay, so how the data space help in PF calculations? So we streamlined, so it will streamline our data collections. So please next slide, click. And we'll ensure the supply chain transparency. So I will just give the main topic. Next one. It will ensure our EF compliance and integrate with the digital battery passport. So this is also mandatory. and it will facilitate the verifications. Okay, so with the help of data space, we can facilitate the verifications, and also it will enable the benchmark and policy. So I will not go to the details because time is already over. And also in the base project, we'll develop the PF tool for the batteries. Okay, so we already developed the GIDEP in our GIDEP project, which is also EU funded project. So we developed the LCA tool, but there we'll use the LCA methodology, but here we will include all the rules what I presented before. So we'll include those things in our PF tool so that the industry can able to develop the get the PF from our tool. So this is also our one of the ambition in the base. So next slide, please. Okay, that is the conclusion. So PF ensure harmonized and comparable LCS. Okay, so we have already the rule books, CFPEV and CFB industry. So challenge exists but can be solved. So our vision is we'll develop the base data space and LCA tool, which will facilitate our compliance battery PF. Thank you very much. So this is
Thank you so much, Faradur. Thank you, Shaheen. We are already over time, so we have many questions. My sincere apologies if we cannot address all. I just maybe stick to one from Anli to some sort of a follow-up on your project to see what is your understanding of the wider adoption of this methodology, both at the public side, maybe the batteries regulation. Have you had any contact regarding that, or other projects that are going just like BASE is using your data? So do you have a vision about that?
Yes. So ideally, the goal, of course, is that most of the projects use it. We are going to try to push the European projects to use it as soon as they have a LCA of a zero emission vehicle to do that. After for next step, of course, there are also the regulations. So the TranSensus LCA methodology is one kind of methodology that can help for future regulation. While we do not say it will be the future regulation, of course, but it can provide some insight to the next regulation. And just for the battery, because here this is many about the battery workshop, of course. Battery is one part of the vehicle. So for the LCA, the LCA of the vehicle, inside there is the battery. So as soon as we can, we have tried to also to consider the rules that were already existing for the battery, and we hope this is compatible. Sometimes it has to be adapted, sometimes it is not correct, but this is the goal, so the ultimate goal.
Absolutely, yes. Thank you. It needs a consideration from many sides. So again, apologies we couldn't answer your questions. We try to contact our invitees and our guests if we can find some answers to those. But for sure, we keep track of them and use them in the next conversation. We will have a lot of work to make this really deployed at larger scale. We are counting a lot on the base projects to facilitate that, so we will have more conversation with them too. So with that, just a quick announcement. The next round of our technology talk will be on October 8th. Our colleagues will share with you the link to the registration. We will talk more about specific technologies, sodium-ion battery, to see within this kind of a landscape that is shifting, what's the situation with the sodium-ion battery, and still kind of repurpose the promise of that. Okay, thank you so much. Thank you to all of you, Shaheen, Farhadur, and Ali, and thank you for all of you who joined us. We see each other next time, but in the meantime, wish you a good day and see you soon. Bye-bye.
Thank you.
Bye.
Thank you.